Okay, it's Wednesday, the 6th of March. Splendid sky tonight. We're supposed to have 3 days of nice, cloudless views during a cycle in which the moon is in abeyance. I just basically added 20 seconds onto the clock because the internal clock on the Gemini 2 runs fast, and so I just randomly decided to stall it for 20 seconds to let sidereal time actually catch up. And look where Rigel turned up. But notice also, it is out of focus. And no matter what I do in terms of locking down focus, we lose it. Well, maybe it's not. Look at that. Well, I guess I've caught it a little late. I was hoping I could reveal to you the 7th magnitude companion of Rigel this evening, but I'm not seeing it. So maybe the focus is pretty good. It looked pretty blotchy to me. What I will do is I'll run down, let's take a look at the settings quickly, just in case by decreasing the settings we can get a smaller resolution, and that does look to be the case, but I do not, oh, well, there is its faint companion. Notice right there at about the 8 o'clock position from the star, we're seeing its 9.3 arcsecond distant companion. I am duly impressed. Very, very nice. So what I'm going to do now is I'm going to go ahead and get everything aligned and set up. In about a half an hour we should have sky dark. And there was a galaxy that was in Auriga, I believe, or Gemini, I can't remember which, that I want to look at because all I've been able to see are galaxies that are pretty far south. I just finished last night's observations and notes for publication, and I basically determined that higher magnifications are not your friend with galaxies. You lose as much in terms of magnitudinal intensity as you might gain, so it's basically a wash. And that'll all be explained in Mathematica Galactica 5, average surface brightness in arc seconds rather than in arc minutes. So there's our look. We're in focus. Time to do some getting the scope synchronized and then come back out in about a half an hour, about a quarter after 7. Here we go. What we have here, of course, is a 256 flood, 42 decibel gain, 6 pass, image stabilized version of Rigel. And I just synchronized to it earlier this evening, about a half an hour ago. It's now a little approaching 7:45. About a half an hour ago I synchronized the scope to it and showed you a vision of it that included its roughly 7th magnitude companion star, some 9 arc seconds distant. Right now we've entered fully into sky dark. The sky looks spectacular. I'm not getting a sense of any high thin clouds. This will probably be the last time out operating at 150x. As mentioned earlier, the math just does not support it. It's just at 1 arc second resolution. The amount of light in most galaxies averages 21 to 22 magnitudes. The scope's only good down to about 16.5 to 17. So even though you're magnifying the galaxy 2 times over than at 75x, you're losing image brightness by dispersing it across the screen more, which means, practically speaking, you don't get to see any more revealed texture to galaxies, even if those galaxies are edge-on, which would be the best possible circumstances. All right, before we start on galaxies again tonight, I'm going to try to turn up ones that are in the middle third of the sky, because we have basically been tracking down galaxies too far south, and I am just going to confirm the Mathematica Galactica work I just released earlier this evening after working on it for about 5 or 6 hours doing the math. Case in point. What we're looking at here is the Flame Nebula, NGC 2024. And the Flame Nebula is fairly bright, but it's also fairly large, which means on a pixel, 1 arc-second pixel basis, the nebula at 30 by 30 arc minutes, emissive type nebula, 1,500 light years distant, is, it's kind of pushing 20, the same 20 magnitude, 21st magnitude. And all we're seeing here is a little bit of luminosity. Now, keep in mind that we have to take about 60 seconds before the image will fully formulate. I read something online today that it says it takes 5 seconds for each of the 6 passes to do so. I had read earlier that it was more like 3 seconds, but the key is, if you've been noticing it, when I do very high image rates, like 250 to a 500th of a second exposure times, the stars jump around quite a bit, which means a lot of effort is going into the software to image stabilize. So I'm hoping we've got enough time here to look at NGC 2024. Another fairly faint 150x view is Casper the Friendly Ghost, which is NGC Messier 78. So let's go take a look at that now that we've given this image enough time to possibly reveal itself faintly on the screen of the Flame Nebula. Of course, if tomorrow night's clear and I go back to the focal reducer, the Barlow lens, we should get a very nice view of the flame, simply because more of its light will be compacted onto the screen. Okay, so we're having a look at Messier 78, a nebula in Orion, magnitude 8.0, smallish, 8 by 6 arc minute, 1,600 light years distant. We're looking at it 150x, and there's hardly any nebulosity present. Once again, there are issues with magnification. Now, you would expect that to be the case anyway. What I'm surprised by is the degree to which higher magnifications dilute the luminosity of extended nebulosity. Now, of course, if we were to look at a globular cluster, it would be fantastic. It's all stars. But when you're looking at nebulosity, there are serious issues. What I'm doing now is synchronizing the optical tube assembly. At high magnifications, you also have to deal with the fact that you are going to lose some tracking and go-to accuracy. I just saw a weird flash on the screen. It suggested that maybe if I do play with the brightness a little bit, I'm going to push it up to 10, that we might get a better view of this nebulosity. Let's give that one more shot to see if we can actually reveal more of the nebulosity by pushing the brightness of the screen up a little bit. So right now I'm going to synchronize to Messier 78, because we're going to go north hopefully tonight and track down a few galaxies in, like I mentioned earlier, the middle third of the sky. Now, I've already reduced the contrast quite a bit in the hopes that we won't see as much pixelation. And I can play with that a little bit, especially now. The contrast is already at 20. That should be pretty good. So let's move on to our first galaxy of the evening, which should be in the middle third of the sky. And unfortunately, when I tracked to it last night, the clouds had already moved in overhead. And looking over my notes, I realized that I wanted to capture a few of the deeper south galaxies before heading north. We've just gone to NGC 2271, a galaxy in Canis Majoris, which we did image last night. It's magnitude 12.2, 2.1 by 1.4 arc minutes, lenticular spiral with a bar, 110 million light years distant. This galaxy is probably somewhere around 70,000 light years in diameter. In publishing today, last night's observing, I used a hypothetical galaxy, NGC 0123, which was the size of Messier 31, 100,000 light years distant, and I did some calculations associated with average surface brightness, etc., to play with a galaxy at that distance and greater distances of different apparent size to see whether or not it made much difference, as well as aspect ratio. And I didn't really get what I would consider to be encouraging results. So here is our image, hopefully somewhere on the screen, is NGC 2271, a galaxy in Canis Majoris. And as I'm navigating towards my next galaxy, an even brighter one, NGC 2272, also in Canis Majoris. Let's look for it. What we're hoping to see here is a galaxy even further south than NGC 2271. This is 72. Galaxy in Canis Majoris. Brighter though, magnitude 11.7, about the same size, 2.4 by 1.6 arc minutes, pure lenticular spiral, 88 million light years distant. We're at minus 27.5 degrees with a right ascension of 6 hours, 42 minutes, and 41 seconds. There's a galaxy in the screen. It's probably that sweetie right there. All we are seeing is the central core region of the galaxy without any real extension, largely due to the fact that we have diluted the luminosity by going to 150x. Well, here's our best shot at seeing a galaxy, a reasonable galaxy, virtually overhead. NGC 2274 is a galaxy in Gemini the Twins, magnitude 12.1, a 2.4 by 2.4 arc minute size pure elliptical, probably a class 0, 231 million light years distant, puts it probably, probably a little larger, probably 175,000 light years across than Messier 31. I'm looking at the screen. I am not sure whether or not going this far north we are getting any view of the galaxy. Ideally, I would be able to center the scope on the caster, but unfortunately it would probably do a flip if I were to do that. I tried it a little bit earlier before we just got started. So here is NGC 2274. I'll allow it to continue to developing the field as I move forward to see if we can find some more galaxies of note. Ideally ones above the celestial equator and further north, with the limitation that roof tries could get in the way above 40 degrees north. NGC 2274 is at plus 33.5 degrees. As it turned out, NGC 2274 had a neighboring galaxy, also in Gemini. I just went right ahead and set the go-to to it because I figured it was very close. NGC 2275 in Gemini is magnitude 13.1, but smaller, 1.3 by 0.9 arc minutes. I also did some average surface brightness on a per arc second basis of smaller galaxies with lesser apparent size, and it really didn't improve the per arc second average surface brightness by much. So there is no recourse there with higher magnifications in terms of seeing anything in particular. NGC 2275 is a spiral of the AB class, which means 1.5 times removed from lenticular, 220 million light years distant, puts it probably about the size of our own Milky Way, 85 to 90,000 light years in diameter. And there's our view. Hopefully it's somewhere on the screen. Let me go ahead and see what our next study is going to be as, there's a galaxy in Cepheus, unfortunately, 85 degrees. There's some kind of group in Gemini. There's a star in Gemini, another star in Gemini. Another galaxy in Canis Majoris, but too far south. An open cluster in Auriga, probably too far north. A nebula in Monoceros, smallish emissive type, which might be interesting to look at, but it's at plus 1 and 18 minutes. So let's go ahead and have a look at this nebulosity in Monoceros. NGC 2282 is a nebula in Monoceros with 3 by 3 arc minutes, emissive type, so it's associated with a star, stimulating its ionized gases to iridescence. 5,500 light years distant, we're at plus 1¼ degrees in declination. Basically, you can treat any kind of extensive nebulosity as though it were a galaxy. So this does not include a magnitudinal value, so it's very difficult to determine whether or not it should be visible on the screen. I'll let it continue to form as we step through, looking for other stars and open clusters. If I come across a globular cluster, I will pursue that. Hey, 2288, a galaxy in Gemini. It's magnitude 14.4 and very small. Let's have a look at that. If we can pick it out on the screen, I'd be surprised. NGC 2288 is a galaxy in Gemini, magnitude 14.4. I expect that we should be able to detect galaxies down to magnitude 15 at 150x, especially if they're near overhead or in the sky's middle third. Small elliptical galaxy, 0.2 by 0.2, which means it's elliptical 0, 226 million light years distant. This puppy's pretty bright given its size. Its numbers would be very interesting to determine based on the various deltas that I've explored in previous Mathematica Galacticas. We're at plus 33.5 degrees. I wouldn't be surprised if it isn't also a neighbor of the previous galaxies we've looked at. Here I go skipping through. Oh, there's another galaxy in Gemini, magnitude 13.2. I'm just going to go to it. And it was just a click away. As you watch it form on the screen. So it did look like there were a number of galaxies associated with 2274, didn't it? Okay, it's got to be the next one. Okay, NGC 2289 is another galaxy in Gemini, brighter, magnitude 13.2, 1.1 by 0.6 arc minutes, lenticular spiral, 229 million light years distant. We're at plus 33 and almost a half degrees with a right ascension of 6 hours and 50 minutes. There's another galaxy in this region, NGC 2290. I'm going to take a break with the camera first before we leap to it. But notice that field of stars. I do believe these two stars were previously on the field. NGC 2290 is another galaxy in Gemini, magnitude 13.2, 1.2 by 0.7 arc minutes. Spiral of the lowercase a, which means once removed from the Z-class lenticulars. 229 million light years distant, and that number seems to be familiar. So this is pretty sure this is a galaxy group sharing a common gravitational well, and they're spiraling together over time, and they will undoubtedly fuse eventually. So NGC 2290, let's see what the next one is. Another one at about the same distance, NGC 2291. Again, not much motion. I'll give you the data on GC 2291. I wonder how the motion detector is dealing with these small clicks, although the stars are pretty much off the field now. NGC 2291 is a galaxy in Gemini, magnitude 13.2, a perfect 1x1 roundish arc minute of apparent size. Lenticular spiral, class O, 238 million light years distant. We're at plus 33, 31, 31 in declination. Okay, the next one's a galaxy in Canis Majoris. That one's 2. Oh, we got another galaxy in Gemini. Should be in the same field. All right, I'm going to shut the imager down and then allow it to formulate once again. NGC 2294 is a magnitude 13.8 galaxy, smallish, 0.8 by 0.4 arc minutes in size in Gemini. It's an elliptical class 6, which means a 2-to-1 ratio in apparent size, 230 million light years distant, so it's part of the same group. We're at plus 33 degrees, 31 minutes, and 36 seconds. And yes, the scope made a little hop, if not a skip, and a jump. And I'll allow that image to continue to formulate. And let's go have a look at an open cluster in Monoceros. Well, quite a spectacular open cluster, NGC 2301 in Monoceros. Total magnitude is 6, 12 arc minutes in size, so it definitely spills outside the screen area, which is only about 7 by 10 arc minutes, probably a little less. There are 80 stars, brightest are magnitude 8. They're pretty blotchy up there. It's an 1-3. Which means stars are probably similarly magnitudinal, but more disparately distributed. 2,800 light years distant. We're at just above the celestial equator on this one. Nice thicket of stars. NGC 2333 is a galaxy in Gemini. Magnitude 13.3, 1 by 0.7 arc minute, spiral of the lowercase a. 215 million light years distant. We're at plus 35 degrees and 10. Our right ascension has progressed quite a bit from the last group of galaxies in Gemini, so this is not part of the group. Frankly, I am having a difficult time actually detecting galaxies on the screen. I would have to watch them evolve on the screen tomorrow over the 6 passes. Stars jump out pretty quickly, but galaxies take a while to develop. 150X is proving even overhead to not really provide the kinds of easily identifiable galactic views that I might have hoped for. Basically, 150X is probably good for things like globular clusters, small open clusters, and especially planetary nebula, but we have yet to encounter one, although I know there's a very nice example in Gemini, but I do not recall its designation. NGC 2339 will probably be the last galaxy of the evening. It's in Gemini, but further south, only at plus almost 20 degrees in declination. If we were operating at 75X, this would probably be a pretty fine view. It's magnitude 11.8, 2.7 by 2 arc minutes, spiral with a bar in lowercase bc, so basically 2.5 times removed, plus a ring, which we should be able to resolve at 75X, except we've diluted out the galaxy's light. Now, frankly, I can't even tell you whether or not any of these galaxies have appeared on the screen tonight, and that's okay. I will probably turn this into another Mathematica Galactica. I'm not sure exactly what I will treat, but something will pop up. I am going to allow this image to continue to form briefly as I skip through looking for a planetary nebula or something really spectacular in the galactic sense. It's a planetary nebula in Monoceros, and it's very close to this planetary nebula will be our final view of what is a very beautiful night sky but a very cold evening. Our final real-time imaging view of the evening is NGC 2346, a planetary nebula in Monoceros, magnitude 12.5, 60 by 50 arc seconds, so 1 arc minute. The central star is magnitude 11.3, and the nebulosity itself is 12.5, so basically about 2.5 to 3 times fainter. This planetary nebula is 4,500 light years distant. It's at right ascension 70922, declination minus 04821. If there is a planetary here, it'll probably be this star right there. You can make out the nebulosity around a rather brightish 11th magnitude stellar disk. Notice how displaced it is to this side of the screen. I'm a little discouraged by that. When we get back to 75X, which should be tomorrow, if we have a good sky, basically things should turn up a little more obviously on the screen. Now, who raises their hands to want to have a view, once again, of Messier 43? I do. All right, so let's go to Messier 43 for our final look-see of the evening. Okay, not nice. It did not turn up where I would hope. I'm going to have to recenter the image. It's at the top part of the screen. So, however, you can see lots of beautiful texture in the nebulosity and the neighboring Messier 42, both of which I will image at lower magnification on the next opportunity, as long as the weather doesn't degrade. On a solid night where the moon is in abeyance, the sky looks very transparent. Let's call this our Carpe Noctem view until our next evening out. Carpe Noctem.